All right, let's continue with area. We're going to continue with some circle stuff, but we're going to also include some area of triangles. This one we're going to need to go back and remember some things from right triangles, special right triangles, and Pythagorean theorem. Let's start with just area of a triangle. This is review. It's the area of a triangle, or the space that a triangle covers, is half the base times the height, or base times height divided by 2. The reason is because that a triangle is half of a parallelogram or a rectangle or square, and so that's why it's half, because the area of a parallelogram is base times height, and a triangle is half of that. Now, base and height are always perpendicular. That's the important part. So you want to look for that right angle, and if it isn't there, you need to create it. So your height and your base are always going to be perpendicular to each other. Now notice in this particular case, I don't have my height. I need that. That's where my right angle is. These are perpendicular. Now, just so you know, every triangle actually has 3 heights. There's that height and that base. There's that base and that height. And then there's this height out here with that base. So there are actually 3 choices. We're going to go with the most obvious. Now in this particular case though, I need that height. If you know your Pythagorean triples, this is a right triangle. This little dotted triangle out here is a right triangle. If you know your Pythagorean triples, which I still highly recommend that you do, 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Still recommend that you memorize those. They're very helpful now that we're not testing actual Pythagorean theorem anymore. Okay, sometimes you have to use it, but sometimes you can get away with it. Well, this is 8. One of the legs is 8. The hypotenuse is 17, which means that the height is 15. See how much shorter that makes your life, right? So then the area of the triangle is half of the base times the height. So 24 times 15, or 12 times 15, if you want to do the half part in your head, you'd get that the area is 180. The perimeter is the distance all the way around. So another thing that you could do is you could find this area, or the perimeter is the distance all the way around. Well, we need to find this length, so I'm going to use anything that I have, which I have this right triangle. Even though this triangle is not a part of it, all I need is that orange piece. So I'm going to do 15 squared plus, this is 24 plus 8, which is 32. So plus 32 squared is equal to c squared. So the square root of 15 squared plus 32 squared is equal to 35.3. So C is 35.3 for 1. We keep our decimals until we're done with everything we need to do. So then my perimeter would be 35.341. So I'm going to take that number and add 17 and add 24. So sometimes you may have to use Pythagorean theorem to find a piece that's diagonal, so that we can get our perimeter. So 76.3, we'll round to the nearest tenth. Perimeter is in inches, area is in inches squared. Okay, now we've got this equilateral triangle here. There are formulas for finding the area of an equilateral triangle. Side squared root 3 over 4. But unless you want to remember that, area equals side squared root 3 over 4, unless you want to try to remember that, you can also have this option of, remember, dropping down that altitude. Now, I'm hoping that you're getting to a point where you can shortcut a lot of these things. Let me remind you also about 30, 60, 90 triangles. Right? 30, 60, 90 triangles, you had your 1, your 2, and your root 3. What that means is this side is x, this side is 2 times x, and this side is x times the square root of 3. Now remember, we set up proportions when we solved that, but it would be so much quicker if you'll get to where you recognize the pattern. Notice that, this is an equilateral triangle, so I know that these are all 60. That means this was split in half, was bisected, and so this side is 10, this side is 20, this is my short side, my long side, or my hypotenuse, and then this has got to be my long leg. That's my root 3 side. This is 10 times longer than 1. 1 times 10 is 10. 2 times 10 is 20. So this side has to be my multiplier. My scale factor is root 3. And so I will do 10 root 3. That's going to be my height. It's just so much easier if you can start to learn those patterns. Now that's my perpendicular. My base and my height are always perpendicular, so you would use this as your base and this as your height. Don't forget the 1/2. The perimeter is easy. 20, 20, and 20 is 60. So it's 60 meters of the perimeter. The area then would be, area is half the base, which was 20, times the height, which is 10 root 3. So 20, keep it, we're going to leave it exact. Unless you're told otherwise, you always leave your answers exact. 20 times 10 divided by 2 is 100 root 3. Now I told you could use this side squared root 3 over 4. You're always welcome to use that. Side squared would be 20 squared, which is 400, divided by 4, which is 100, and then root 3. So you get the same thing, and that would be meters squared. If I asked you to round that or give me an approximate answer, it is approximately 173.2 meters squared. You would just simply multiply out that square root of 3. But unless you're told to round or to get an approximate answer, always leave your answers exact. Okay. Now on this one, we notice that this has this 50 degrees. We have our base and our height. We find that perpendicular, right? Your base and your height are always perpendicular. The problem is we don't have the height. But this 4 is here for a reason. That's going to be helpful. What we want to do is we want to take a step back and we want to use this triangle right here, just that little yellow piece. So on this one, what you want to do is you're going to have to use trig. We want to know the height. We have the hypotenuse and we have the opposite side. So I'm going to take a step back for just a second to go get the height. So that is SOH. Remember we had SOHCAHTOA. Okay, so SOHCAHTOA. So we need opposite and hypotenuse. So that is the sine of 50 is equal to the opposite side divided by the hypotenuse. You would multiply those together. Make sure your calculator is set in degrees. 4 times the sine of 50. To check and make sure your calculator is set in degrees, remember to go to mode. So that is 3.064. That's my height. 3.064. Now let that sit there. Don't erase it, right? And then we're going to do the area. The area is half the base, which is 7, times the height, which is that number. So we'll multiply 3.064. We're going to keep it in the calculator, times 7 divided by 2, and we get that our area is 10.7. Now, with trig, there's no way. You have to have decimals. So you can't get away with leaving anything exact. Now number 4 is a little bit tricky because what you notice is if I want x, well, in order to find x, I don't have enough information. I don't have any angles. I don't have Pythagorean theorem. I can't resort to anything. So here's what I do want to do. What you notice is that we can find the area. I mentioned earlier that every triangle has 3 bases and 3 heights. You just have to use one of them. It doesn't matter which one you use, just pick one. Well, what I notice is I have this base and this height, but I also have this base and this height. And actually, that yellow base and height is more useful for me because I can actually do the math with it. So let's use that to get the area of our triangle. So the area of our triangle is half the base times the height. So the area of our triangle is 60. So that's the area of that whole triangle. Well, now, if we flip it around and look at it where this is the base and this is the height, the question is, what's the height when we're going that other direction? The area of the triangle doesn't change just because I flip it over and now use this base and hit this height. So it may look a little bit better looking at it like this. So the area of the triangle is 60 is equal to half the base times the height, or in this case, the height is x. Okay, so half of 30 is 15, so 60 is equal to 15x. So 60 divided by 15 is 4. So the height in that direction is 4. Okay, remember your height can come off of the side. Always look for the perpendicular, but what we found is that the height in the direction of the green measurements is 4. Now, we're going to take that. We needed the area of the triangle because what we're going to start finding is the area of the segment. So the area of a segment is a portion of the circle. What it is it is the area of the sector, right, that piece of pie. It is the area of the sector that we found yesterday minus the area of the triangle. And really this should have gone over here into the formula because there's not really a good, there's not a formula for it, right? So the area of your sector minus the area of your triangle. So remember that the area of your sector was theta divided by 360 times pi r squared. And then the area of your triangle is 1/2 the base times the height. And so you're going to have a lot of pieces of information to be able to do that. So you really have to write neat, keep organized, and keep up with what you're finding. Okay? So if I want to find the area of this segment, I want this shaded area. Basically what you want to do is you want to start by finding the area of the whole thing that it belongs to. Okay, so this is a quarter of a circle, so there are several ways that you can think through this, but I'm going to start with the quarter circle. Okay, the quarter circle, so the area of the quarter circle would be 90 degrees out of 360 degrees is equal to the area of the segment divided by the area of the whole thing, pi r squared. Okay, so keep that, so 90 divided by 360, or 1/4 of the circle, times 12 squared, which is 144, and we get that the area of the sector is 36 pi. I did not use the pi key. Don't use the pi key. Leave it. These answers are going to be really ugly. You're not going to like them. Okay, that's the area of the sector. Well, now what I have is basically I've taken that circle, I've cut it into pieces. Right, I've cut out that quarter piece. Now I'm looking at, this is all I'm looking at now. And now I want to cut off that triangle. I want to cut off that right triangle. Well, the area of the right triangle is the base times the height. Remember that the radius doesn't change as you go around the circle, so this is also 12. So your base and your height are 12. So the area of your triangle is half the base times the height. And you get that the area of the triangle is 72. So I'm going to take the area of the sector, right, the area of the sector, and I'm going to take away the area of the triangle, and I will be left with that little edge of space. So you take the area of the sector, 36 pi, and you subtract the area of the triangle, which is 72, and you leave that alone. That's your answer. So it looks pretty ugly, but you can get an approximate answer, 36 pi minus 72. Always make sure that it's positive, right? 36 pi minus 72 is 41.09. So you just want to make sure that you don't end up trying to take away more than you have. Okay? Now, let's look at, what if we have this triangle right here, this obtuse triangle? We're still going to do the same thing. So we're going to find the area of our sector first, right? Find the area of your sector. So the green piece is the number of degrees, so it's 1/3 of the circle if you want to think of it that way. 120 out of 360 degrees is equal to, right, our fractional part over whole is equal to part over whole. So it's the part of our sector divided by the area of the whole thing, which would be pi r squared. So 1/3 of pi r squared. 64 divided by 3 does not come out nice and pretty. We don't want to use decimals, so we're going to just leave it. Math, enter. 64. So the area of my sector is 64 pi thirds, or if you like better, 64 over 3. 64 thirds pi. You can leave it either way. All I did was, you can do 64 times 120 divided by 360. As soon as you get that decimal, let the calculator do the work and turn it back into a fraction, right? 120 times 64 divided by 360, and you'll see that it comes out, right? So we don't want decimals, especially repeating decimals. So math, enter, and it turns it back into a fraction for you. Leave your answers exact when you can. And we can, so we will. Then we're going to take away this triangle. Okay, now it gets a little more complicated. There are two different ways to do it. I'm going to talk about one, and then I'm going to show you the easier way. One way to do it is to use this as your base and this as your height, like we did on that one triangle a second ago when we were trying to, when we were finding both, we were using the two different heights and bases, right? This is kind of the idea that we're looking at. So one option is to do your triangle like that, like your green markings. The other option, which I think is much easier, is to use those yellow markings and to let the height be outside the triangle. So here's what's going to happen. If you extend that diameter, I want the area of the triangle, y'all. Here's what I'm going for. I want the area of the triangle. To find the area of the triangle, I need the base of the triangle and the height of the triangle. So here's what I'm going for. I want to make this easy on myself, and so I want to use this base and this height. Now, believe it or not, it really is easier, less room for mistakes. Now, notice that the hypotenuse is 8. Now, here's something really important. If this angle inside is 120, then this angle out here is 60, linear paired. Now, 30, 60, 90 triangles. The hypotenuse is 8, right? The short side is going to be 4, which I don't really care about because I don't need it. And the long leg is 4 root 3. This is why you really got to know how to use that now, the short way. What that means is then the base of the triangle, if I turn it like this, right? The base of the triangle is 8. The height of the triangle is 4 root 3. So we find the area of the triangle. The area of the triangle is 1/2 the base, which was 8, times the height of the triangle, that outside height, 4 root 3, so you get 32 divided by 2, that is 16 root 3. This is the ugliest answer, y'all. 64 thirds pi minus 16 root 3. Now, like I said, there's alternative ways to do that, to find the area of that triangle, and if it makes more sense to you, then do it this way. If you like that height to be inside, I just turned it like this. That's 120. That's 8 and that's 8, right? So we just turned our triangle like this. If you need to, turn it. Drop that height down. You've bisected that angle. It's 60 degrees. But you know what? You're still going to end up, this is your long leg, your 4 root 3, and this is your short leg, 5. Now, here's the problem, is you forget how to double this. So this would be 8 root 3. And then your height would be 4. So look, you get half the base is 8 root 3 times 4, or 8 times 4 root 3. Either way, you get 16 root 3. So it doesn't matter. Use whichever way, but either way, you need to be familiar with your 30, 60, 90 triangles. It makes life a whole lot easier. Now, this one. This one you actually have a couple of options also, and I'm going to show you the easier way. The harder way, you have to use trig. But the easier way, you don't. Okay, and that's always nice. So it says that the central angle of the segment is 150 degrees, so this angle is 150 and the radius is 15. You want the area of the segment, that shaded piece. So first thing, we're going to find the area of the sector. Okay, area of the sector. It is 150 out of 360 degrees. I don't know off the top of my head what fractional piece that is. Part over whole equals the part of the area of the sector over the area of the whole thing. Pi times 15 squared. So I'm going to multiply this out, right? Or multiply and divide, divide and multiply. 150 divided by 360. Okay, that's my fractional part, times 15 squared. Okay, now again, I want to use exact answers. I don't want to keep decimals. So this is going to be 375 fourths. So the area of my sector is 375 fourths pi, because I didn't use pi. Now, notice it's 93.75. It would be okay to leave 93.75 pi, but it's always better. I just hate to mix decimals and exact numbers like pi. Okay, so that's my area of my sector. So you can see this is going to get really ugly. So here's something that you can do, right? Just like we did a minute ago. Let's extend that diameter all the way across. Drop down that altitude. Here's my base. Here's my height. Now the reason that I like this way, because I don't have to use trig, notice this is 30, because those are a linear pair. This side is 15, so now I can use my 30, 60, 90 triangle. So this side is my short leg. Across from the 30 is your short leg. It's half the hypotenuse. So the height is 7.5 or 15 over 2. We're going to keep 7.5 for just now. 7.5 is easier to use. So the area of your triangle, see, that's easy now, right? There's your height, there's your base. I'll show you the other way to do it, but this way is so much easier. Then the area of the triangle is equal to half the base, which was 15, times the height, which is perpendicular, 7.5. So 15 times 7.5 divided by 2. You get 56.25. We're going to math enter that back into a fraction. That is 225 fourths. No pi. Don't throw pi on there. That's a triangle. We don't need pi there. So we subtract them. 375 pi fourths minus 225 pi. You could combine those, 375 pi minus 225 pi over 4. You could do that. Okay, now I know that's ugly, and that's just the further you get in math, the uglier the answers get. Now you could have also, if you prefer your base and your height to be inside your triangle, you could have turned it like this. Zoom in so you can see it, but you would have to use trig. You could drop this height right here. It's going to bisect that angle and give you 75 degrees. What we have now is a 75-degree angle with a 15 unit hypotenuse. So you have to find the height and you have to find the base, or half of the base of that triangle. That's why you have to use sine and cosine to be able to do that problem. So that's why it gets kind of complicated. If this comes out to be, if your triangle outside comes out to be a 30, 60, 90 triangle, it gets a whole lot easier. Now, if you use sine, cosine, and tangent, there's no way around it. You can't be exact. You have to use decimals. But because I was able to use that 30, 60, 90 triangle, I was able to use my exact numbers and not have to round anything. I did double check. They do both work that way. Okay, so the area of a segment, to find the area of a segment, you would find the area of the sector, the big piece of pie, and then subtract away the triangle. Find the area of each and subtract them and get what's left.